Okay, my dear students, the next topic is that we are going to study about the body projected vertically from top of a tower. So here I am taking a tower. Okay, I am standing on the top of a tower. From there I am throwing a body. Okay, let us say that. So this is a building. Okay, at the top of the building, we people are standing. Now you are throwing a body. A ball, you are throwing it upwards. So in that case, what will be the distance moved by the body? Body projected vertically from top of a tower. So this is what is the subtopic that we are going to study now. So here I am taking a tower like this. Okay, T-O-W-E-R. This is tower. So from the tower, from the top of a tower, you are throwing a body with a velocity u. So it reaches at some height, again it drops like this. So this is what the concept we are going to study. Okay. So now this concept, if you observe, it can be applied in three different cases. That is, first case is that whenever a body is thrown from the top of a tower vertically upwards. And second thing is that a body dropped from a rising balloon. So balloon is there, okay. On the balloon you are standing. Now we are dropping a body. A body dropped from a rising balloon. This is second case. Third case is that, so you are projecting a body, okay. So you are in a helicopter. Let me say that the helicopter is moving up vertically with a velocity u, and you are simply throwing a body. In such case also, all these equations are applied, okay. Now let us derive this. Let the height of the tower be h, and this point is the maximum height. So you could write this one as maximum height. You will know that at maximum height the velocity is equal to 0. So here, from here you are throwing, so let me name this point as A. So the velocity at this particular point is u. It is reaching to the maximum height, let this point be B. So the velocity at maximum height be 0. And thereafter it comes down here, again it falls onto the ground, okay. So in this case, we are going to study about its factors. That is, S is equal to ut plus half a t square. So this is what the basic equation that we know regarding its distance. When body is throwing up, what we have to say is that acceleration a equal to minus g. When a body is throwing up, we have to say that acceleration a equal to minus g. Okay. So let me substitute here. Here the distance s is nothing but height of the tower, that is h is equal to, you are throwing up with a velocity u into t plus half, whereas the acceleration is minus g into t square. Okay. So this minus comes here, h is equal to ut minus half gt square. Like this will write. Okay, my dear children. This is what the basic equation is studied. But that is not applied in this case. We have to do small modifications. Now let us see those modifications, okay. So this is point A, this is point B. Let me name again, since this is A, I can say A, and let me name this point as C. So here what I have to say is that I have to consider the distance that has been moved by the body. That is from point A to B. So I have to write A and then to B, and B to again A, and then from A to C. So like this I have to consider, my dear children. In such case, how could I take h? I should not take no. Yes or no? I should not take h. So let me erase that. So then what I have to take? Okay. So distance from A to B, and then B to A, and then A to C. Like this I have to take. Observe carefully. So here I am now not telling any kind of distance. Okay. So from here to here, if I take it as x, it is upward journey. Then from here in downward journey, I have to rename it as minus x. If this is plus x in upward journey, minus x it is, downward journey it is minus x. Here it is h, so downward journey it is minus h. Like this I could write. Okay. So you are starting from A and then to B. So first distance from A to B, and then from B to again A, and then from A to C. So from A to B it is x, okay. From B to A it is minus x. From A to C it is minus h. So this is what the thing I have to take. So plus x minus x is cancelled. Now answer is minus h. So distance from A to B to A to C. This is what we have to take here. Okay. So this one minus h. Understood now? So now let us move this minus to other side. So h is equal to minus ut plus half gt square. Like this I am going to get. Solve this. So this is what the equation which represents a body thrown from top of a tower. Very, very important equations. Previously we have studied three different equations. One is h is equal to half gt square, that is for a freely falling body, okay. And again h is equal to plus ut plus half gt square, that is for a body projected in downward direction, clear. And third one is that when a body projected upwards, you are taken as h is equal to ut minus half gt square. So those three are different cases. This is again different case. This is the only one equation which is entirely different in this motion in straight line topic. So you have to remember it carefully. Very, very important. So here if you observe, in place of u I have taken as minus u. Okay. H is equal to minus ut plus half gt square. This equation represents for a body thrown vertically upwards from ground or from top of a tower. That is from top of a tower. So whenever we say that a body is thrown from a top of a tower, here immediately you have to recollect its equation like h is equal to minus ut for ut plus half gt square. Not only from top of a tower. I told you, ball dropped from a rising balloon. A balloon is just rising upwards. So immediately your ball is dropped. So there what you have to apply? This is the equation because a ball is going up, right? Understand now? A balloon is rising upwards, a ball has been dropped. So it is similar to a body projected from top of a tower. Clear? And the third one is that a body dropped from a helicopter which is rising vertical upwards. So now this is the basic equation by which we have to solve any numerical question related to a body projected from top of a tower. Understand? Not from the ground. It is from the top of a tower. Whenever you say that the body is projected from top of a tower or from a body has been dropped from a rising balloon or a body is dropped from a helicopter which is rising vertically upwards with a velocity u. In those cases, we have to use this equation, that equation, h is equal to minus ut plus half gt square. This equation is completely different compared to relative equations in physics. So very, very important, my dear children. Now after getting this equation, now we have to find out the time taken by the body to reach the ground. What are the body you are throwing up vertically with a velocity u, okay. It will reach at some point, again it will drop to the ground. Now my question is that after what time it will reach the ground? How much time it will take to reach the ground? That is what is my question. So what? How to find out the time? Okay. Then by using this equation, we could write it as, since it is h is equal to minus ut plus half gt square, we could write it as 2h is equal to minus ut plus gt square. So like this you are getting, after bringing to this side, it is gt square, okay, plus ut gt square plus ut plus 2h is equal to 0. Like this I am getting, my dear children. So my interest is that I have to find out the time. I could write this as gt square minus ut, bringing 2h to other side, it is minus 2h is equal to 0. So like this you will get the equation. Now you tell me, how to find out the time? In this particular case, a body has been thrown from the top of a tower or from a helicopter, it has been dropped. So we have to find out the time, how much time it takes to reach the ground. So how to do this? How to solve this? So every student has this kind of doubt. So look at this carefully. I have written this in the form of quadratic equation. Quadratic. That is ax square plus bx plus c equal to 0. So if you observe carefully, in place of a, g is there. In place of b, minus u is there. In place of c, minus 2h is there. In place of x, t is there. So like this I am getting. Okay. So now for this equation, you know how to find out the roots. Yes or no? So for this particular equation, we have to find like this: x is equal to minus b plus or minus root over b square minus 4ac by 2a. Now whatever a, b and c and x here, you please substitute there, you will get the answer. Okay? I hope you will solve this, or else I will tell you. So take a screenshot of this. I am giving you 2 minutes time. You better take a screenshot of this. Later on I will erase it. So let us substitute this and see what is going to happen. So in place of x, I told you that it is x is equal to minus b plus or minus root over b square minus 4ac by 2a. In place of x, there is time t. In place of b, there is minus u root of minus u whole square. 4 into a is g, c is minus 2h. Like this you are going to get, divided by 2 into g. Okay. U plus or minus u square plus 8gh by 2g. So like this you are going to get. This is the way we have to find out the time taken by a body which has been projected from top of a tower to reach the ground. So from tower, so tower means it is at some height, right? From there you are throwing and it is going to some highest point and thereafter comes down. So now what is the time taken? This is the way we have to solve it. Okay, my dear children, you better take a screenshot of this one. Now what is the velocity of the body on reaching the ground? So the diagram is like this. I have taken a tower. Okay, a body is projected with a velocity u. It goes up and then comes downward. Here what you are saying is that the height of the tower is h. We have assumed that this point has a, whereas this point has b. Okay, since this is a, this is also a, let me assume this point as c. So like this we have taken. So my interest upon is that at point A the velocity is u. Okay, let me write here. Velocity at point A is u. My question is that what is the velocity at point C and at this maximum height, whether I say or no, you know its value. What is the velocity at maximum height? It is equal to 0. So velocity at this point B is equal to 0. Now my interest is that I have to find out the velocity at point C. So here we know the distance as h between these two. The distance is h. How to find? How to find its velocity at point C? Again, basic equations, my dear. Two velocities are given and distance is given. Two velocities and distance is given. So how to find out? We have to go for kinematic third equation, that is v square minus u square is equal to 2as. This is what the third equation. So you are coming from A to C. Okay. So let me write here A to C, where A stands for initial and C stands for final point. C stands for final. So this is initial and this is final, and distance from A to C like this. Okay. So now I don't know this Vc, but at velocity at point A is u. So you have to write it as u only, which is equal to 2. In place of A it is g. Okay. Now the distance traveled from A to C is h. So the velocity Vc square is equal to, going other side, u square plus 2gh. So velocity at point C is equal to root over u square plus 2gh. Like this you have to find out the velocity at point C. Okay, my dear children, you better look at this carefully. Okay. Take a screenshot of this. Take a screenshot of this. So with this, I am ending this topic. Okay.